Hey, welcome back to the shop. Today I wanted to make a small arbor, like this, a stub mill arbor for this gear cutter. In the future I need to cut a gear that looks about this, except for not being broken. But somebody lent me or borrowed me this gear cutter, and I really have to be thankful for that because those cost real money, and I only have to cut one or two of these gears in plastic. So yeah, I got this gear cutter, but obviously this has a 22mm bore and I only have a 16mm arbor for some reason. But I have a lathe and I'm cheap, so I'm making my own arbor. And I'm going to use this piece of steel, and this is a piece of a big screw. As you can see, this is a very fine pitched, big diameter screw. This has a pitch of about this has a pitch of 1.5mm and the outer diameter of 36mm. So this is a 36 by 1.5mm piece of all thread, and it's high strength steel, and those were used to bolt down the crane on the chassis of a big truck. A friend of mine gave this to me, and I use this when I can't heat treat the part, because this is already heat treated to a very high strength and it's pretty tough stuff. So we're going to lob off a piece of material about this length and turn our arbor. That looks almost like this, only with a 22mm end. There we go, that's our piece of material. Okay, right now I'm roughing down the material to the rough dimensions. I'm doing this in this recharge chuck, and as soon as this thing has cooled down, when it's all roughed out, I'm going to set it up between centers and do the finish turning. I'm running a high-speed steel tool at pretty low speed, about 200 RPM, and a feed of 0.07mm per revolution. And the chip that comes off is nice and curled, very controllable. No bird's nest of chips around the tool, and the chip is nice and blue. But the tool is still holding up very well. I didn't have to regrind it once as I started, and all the heat is going into the chip, so that's perfect. Okay, I roughed out the arbor with about 1mm allowance on all surfaces except for the faces. There's only a few tenths on there. Next step will be to cut the keyway slot, or the slot for the key, because I anticipate that it might warp slightly when I mill in the slot from one side. So I'm going to mill the slot before I do my finish turning. So when I do the finish turning, I will remove any warpage from the milling. Okay, off camera I milled the keyway slot into the arbor, into the 22mm end of the arbor, and I fitted a key into it, which fits very snugly. And now I have to remove the key, of course, again, because I was just checking my fit, and machine it to final dimension on the lathe. The way I like to remove a close-fitting key is to grab it with the sharp edges of my vise, which has copper jaws right now. But this will work anyway. Grab it tightly and then work the arbor off the key. And due to the copper jaws, you don't hurt the key. You can also use a precision ground vise, like a grinding vise or something like that. That will also not hurt the key. If you use a bench vise with heavily serrated jaws, you will mangle up the key. So have either copper jaws or ground and hardened steel jaws for a bench vise. I see no need in serrated jaws, at least for semi-precision work. In a fabrication shop it might be different, but I'm no fabricator. Okay, I set the arbor up between centers, and I'm always using a lost center. That's just a piece of round stock that I chuck up in the 3-jaw chuck and turn through as I use it. So I have always a dead true running dead center on the headstock side. I have my lathe dog, and I let the lathe dog rest against the jaw of the chuck. And I had to add the screw and bend it over slightly so it gets catched by the jaw. On the other end I just have a live center. Oh, and that's my setup for turning between centers. First we will cut the 22mm diameter here. Take a light skim pass on this other diameter, which doesn't really matter, but I want it to run through anyway. And then we're going to cut the morse taper. We will flip it around and cut the morse taper. And we get a nice short chip because of the interrupted cut. Okay, I got it down to 22mm total over the complete length. And now we're going to take a skim cut on this register surface, or this register diameter, and machine a chamfer here, here, and over here. That's the nice thing when you're machining between centers. You can take out the part as often as you want and don't lose any precision, as long as your centers and as long as the centers are clean. Okay, I took this cut with power feed, and I don't bother with any measurements on this diameter because it doesn't matter. This is just material. This surface is important. I faced this off when I turned the diameter for the milling cutter, and of course the diameter itself is important. Okay, now we can take out the part, flip it around and machine the morse taper. But for that we need of course to set the the top slide to the angle of the Morse taper. And for that we need a master taper. In the past I used my Morse taper to test bar, but if you don't have one you can also use a drill chuck arbor, for example, which has centers on both sides, and you can clamp it up between centers, check if it's true running, and then indicate your top slide along it. To clean the center bores on the ends of a part, again you can use this soft eraser, this art store eraser. You just press it in there, and the eraser collects all the dirt from the center bore. Works also on the outside of the live and dead center. Sometimes better than using compressed air. I'm setting up the arbor between centers. Make sure it's nice and subtle in there. Okay, and I showed how to set up a Morse taper turning when I did the saw arbor video, so I'm not going to show this in detail. Okay, I set the top slide up at the required angle, and I made a drive dog for the 22mm end. As my regular lathe dog, which is my only lathe dog, doesn't fit over a 22mm diameter. It maxes out at 20mm. So I took a piece of scrap that already had a 22 point something millimeter bore in it. I TIG welded a piece of steel to it, drilled and tapped it for a set screw, and that's my lathe dog. Took me about 5 minutes. Included finding or searching the piece of scrap in my scrap box. So now we can lock it down. I make sure that the set screw goes into the keyway so I don't mangle up the nice precision diameter out here. Lock it in place, and now we are good to go. Make sure that our centers are clean. And take it up between centers. And you should be able to rotate it between centers. You shouldn't lock it up completely, but it should be nice and firmly, especially when you're running a live center. If you're using a dead center in the tailstock, it should be a bit more on the loose side. Otherwise you will burn up the dead center. But I'm using a live center, so no burning. Now I can set up a tool, and we can cut this taper. The drive dog should work as I intended. The piece of steel rod gets catched by the jaw, and everything's fine. Last time I turned the taper, I used my trusty old Makita cordless drill with a socket extension and a universal joint to drive the top slide. But then I saw a video from Tony, this old Tony, which I think is not as old as he states, and he used something like this, the T-shaped driver, which engages the two crank pins on the top slide like this. And I liked this, so I copied it, like the Chinese. Okay, I took a few passes with the power feed, and now I'm checking with a Morse taper 3 to 2 adapter sleeve to see how far the taper goes into its socket. And when I look in here through the drift slot, I can see that I can go a bit farther on with turning down the taper. Right now we're a bit far out. If I take a commercial Morse taper 2 arbor, you can see that the end protrudes into the slot of the Morse taper 2 socket. So let's take another fine cut and see how it goes. Okay, I got the taper to a good fit, and I checked the runout in the milling machine, and everything is fine. We're well within 200ths of a millimeter overall. I will show the runout to you later. Now we will clamp it up in this recharge chuck here on this diameter, drill and tap it for the screw that holds the milling cutter. Then we will flip it around and drill and tap the drawbar thread. And not to mangle up the surface here, I'm using some brass shim stock between the jaws and the part, so I can crank down, because tapping a 10mm thread takes some torque, and I don't want the part to slip in this recharge chuck. Leaves ugly marks on the part all the time. Okay, I drilled and tapped the first side for the where the milling cutter goes already, and now I do the drawbar side. Already pre-drilled and chamfered and slightly counterbored the hole, and I have my 10mm tap in the keyless chuck. You hear often that the keyless chucks don't have enough holding power for threading, and this is not even a Albrecht chuck. This is a more cheaply made Röhm Supra, and those cost about a third of an Albrecht chuck. And even this one, Röhm is a German company, by the way, even this one is way good enough to hold a 10mm tab without slippage. These chucks tighten themselves when the tool wants to slip. But when you reverse the machine and it runs counterclockwise, the chuck will loosen and then the tab will spin. You will see what I mean in a second when I do the power tapping. Easier to show than to explain. Okay, slow speed. Okay, power tapping 10mm. There we go. You saw it tightening? There we go. Now we bottomed out, and when I set the machine to run reverse, oh, didn't even. Normally the chuck opens then, and then you have to counteract by tightening the chuck until the tap is out. But worked out fine, and still opens up with the twist of a hand. So I think there is no reason to use a keyed chuck anymore. We have 2016 and keyless chucks work, and there are even ones that are that have a safety against opening when run reverse. So yeah, I think I don't have a single keyed chuck in the whole house anymore. Not even on the hand drills. Everything has a keyless chuck. So now we have our 10mm drawbar thread, and we can try it out on the mill. Okay, I have the arbor in the spindle tightened up with the drawbar, and I set up a 100th of a millimeter dial indicator. And let's you see pretty exactly 100th of a millimeter run out on the extreme end of the arbor. And in my mind that's good enough for a shell mill arbor. Okay, we get pretty much almost zero run out on the face of the arbor. And we are touching, so this is a true reading. So this face runs perfectly true as it's running true. And the diameter on the extreme end is about 100th of a millimeter off because the taper is the morse taper 2 is only 99.99% fitting to the spindle. But I think 100th of a millimeter run is good enough, at least for me. Okay, the arbor is finished. I had one spare arbor screw in one of my drawers with a 10mm thread that fits the 22mm arbor size. But I don't have a single 22mm arbor ring, and I need those to fill up the space between this shoulder and the milling cutter, because I made this arbor, of course, long enough so I can also clamp up a shell mill or whatever onto it. And the gear cutter is of course very narrow, so I need some arbor rings, and you can buy them. They're pretty expensive because they are hardened and ground on the thickness, but I have a lathe, so I'm going to make my own out of this piece of free cutting mild steel. Okay, I took the material, I turned it down to 32mm outer diameter and bored it to 22.05mm, and now we're going to part it off. There we go. Now we can go to the shaper and cut the keyway. Okay, that's the setup on the shaper. I changed the clapper box to my slotting head with a 5mm tool. Because I don't have a 6mm tool, I have to offset 0.5mm to each side to get a 6mm keyway. I have an angle plate here, and I clamped the bushing against the angle plate. Pretty basic setup. On the other side down here you see the dial indicator I'm going to use to offset the table, 0.5mm, and here you see the strap clamp I need to hold my angle plate, because the hole pattern of the angle plate does of course not match up with the shaper, even if I drilled the hole pattern myself, but for some reason the hole pattern doesn't match up in any way with the shaper. Okay, this is a bit of a strange shot. You're looking through the slot of the angle plate into the bore of the bushing, and the black thing you you can see there moving is the front of the shaper tool. Now you will see how I center the tool in the bore. I'm going to touch off. And as you can see, we only get contact on the left side on the left edge of the shaper tool. That means we need to move a bit over to get it centered. The goal is that the slotting tool leaves two equally sized marks in the bore of the bushing, and then we are centered. Ooh, wrong direction. That's a bit finicky and takes some time. Okay, now we get a mark on both sides. And we get a chip that's about the same size on both sides. I think. Hard to tell. Yeah, it's the same size. It looks bigger on this side because the front of the bore is completely out of focus. The depth of view that close up with my camera is very little, so you only get a very shallow area where the image is sharp, and that's about here. So now we are centered. We can zero our dial indicator and cut our key. And that's effectively the only way I know to center the slotting tool in a bore. You could use gauge pins of both sides of the tool against the wall of the bore, but that sounds like a lot of work. Okay, we have to go down 2.5 millimeters. Let's get some cutting oil in there, get the machine going. There we go. That should be our final dimension. Okay, I cut the rings apart with parting tool, of course, and into individual rings, and now last task is to machine them to thickness and exactly parallel, and for that the magnetic chuck is of course the best solution. A surface grinder would also be nice, but those are not hardened, so we can machine them with a defined cutting edge opposed to a non-defined cutting edge on a grinding wheel. I get often asked how you set up the part on the magnetic chuck, and it's really easy. There is always some residual magnetism in the chuck, so it's right now turned off, but the part still sticks on. I stick the part on, make sure everything is clean. Then I spin it just by hand and adjust it so it runs true by eye. Then I switch the magnet on. Part is locked now. Now I can bring in a dial test indicator. from above. And check our run out. And we get about 0.35 mm of run out. So, and we use a copper drift. To knock it in place. You search for the high spot, just tap it half the run out, and then you get pretty much zero run out within a few seconds. And you remove your dial test indicator, check if the magnet is really on, otherwise this will fly off, and you can face off the end of the part as you want. There we go. First side faced, chamfered on the inside and outside, and I'm using again the Aux Tool Co. Universal Lathe bit. And we turn off the magnet, pull off our part, get rid of the chips. You can just wipe it down with your bare hand. The chips don't really stick to it when it's switched off. You make sure the part is clean. Doesn't hurt to run it over some fine emery paper to remove any slight burrs so you don't scratch your magnet. We stick it on the magnetic chuck and look for our run out. Okay, bring in our dial test indicator, switch on the magnet. And we have a bit more run out this time. I don't really need this kind of precision in the run out, but I want the chamfer I'm putting on there to run true to the part because it looks ugly if that's not the case. There we go. Surface both sides and should be perfectly parallel in thickness. I didn't machine it to a specific thickness because it doesn't matter. I only need them to be parallel. Okay, we're over at the bench. I'm using a small needle file to deburr the key. It's a bit hard to work around the camera. I'm literally hugging the tripod right now. Breaking all the edges and also break the corners slightly. And you see that my thumb is guiding the needle file along. It's acting as a file guide so I don't run with the file into my surfaces. Then I use my eraser to get off the crud, and the chamfering tool made a slight burr on the inside, so I'm using a Noga tool with the narrow deburring blade. I like these because they cut a bit softer than the regular ones. And I'm taking off the spur. There we go. Okay, let's wrap it up. We have our arbor. We have the rings, which fit quite nicely onto the arbor. And we have our gear cutter, which we will need in the next project, which should also fit on there, quite nice. And we have another ring. Which should also fit. Come on. We need the bigger ring because the other one is too thin. That's the reason why I made more than one ring. And our screw to hold the milling cutter in place. Tighten this down, set it up in the milling machine, and we're good to go. Neat little project. Could have bought it on eBay for 50 bucks, but I made this my own, and buying means losing, so thank you all for help. Hope this is quite interesting for you, and thank you for watching. See you next time.